Hi, good afternoon. Uh, I'm Junshik from Line Plus Media Platform, and I think we have a lot of developers here. And I wonder, have you ever tried to apply cutting-edge deep learning technology to your service? Have you? If so, was it easy? How was it? I guess not. Today, I'd like to talk about how Line is applying vision deep learning technology to various services. Have you ever tried this? This is Line's OCR service, and you can extract all the text from the image and translate to your familiar language simply by capturing or choosing an image from your photo album. So the question is, how is this possible? This is possible thanks to PicCell. By simply sending an image to PicCell, PicCell extracts all the text from the image. So today, I'm going to talk about PicCell, which is Line's deep learning platform. I'll begin today's presentation with why and how PicCell was made, and some interesting case studies will follow. At the end, I'll wrap up today's presentation with our roadmap. Line is very popular service all over the world, and Line has a lot of family services. Despite their excellent, they are facing their own challenges. And as deep learning technology gets more popular, they were all planning to solve their problem with this deep learning technology. But as you know, finding good deep learning engineers is quite difficult. And deep learning even costs a lot. So even if they develop their own deep learning technology, it's very difficult to take benefit from it, considering the cost. The other challenge is that there are some overlapping functions among different services. So we thought if somebody surveys all the needs from each service and figure out common needs and provides those functions to services, that would be awesome. Because we can aggregate all the resources and we can also save cost a lot. So we came to a conclusion that a platform should be made that provides commonly required deep learning functions to various services. So we have developed PicCell, a platform for common deep learning functions. Like the name suggests, PicCell handles only vision deep learning functions. Because we thought the other field of deep learning technology includes too many service-specific needs. That's why we started to focus on video area. So we developed some vision deep learning functions, and sometimes we integrated well-made functions developed by others. For now, more than 40 Line family services are using PicCell, including Line itself. The question is, who's gonna do this? All the service developers were very busy to develop their own services, and this should be commonly used platform. So we thought platform developers should do this job. So we, media platform, is right team to do this job. Media platform handles all the files across whole Line services, and more than 80 Line family services are using media platform now. And media platform is running OBS, which is a huge media storage platform. And OBS has been running ever since Line was made. OBS handles all the video, image, audio, and any file types of Line services. And OBS stores them, delivers them, and processes them. And since OBS is handling all the files in Line services, traffic in peak time is about 1.5 terabps, and the whole storage volume is about 100 petabytes. So we can say OBS has all the target source for vision deep learning function. Media platform is familiar with developing platform, like the name tells. And media platform has all the media. And media platform is the expert in media. So we thought PicCell, which is for understanding media, should be made by us. So we have decided to develop PicCell. Then what's the top priority? We started to survey the most common and the most prior needs from many services. And we could figure out that detection of adult contents is the most urgent and useful function. Since this adult content is the main cause of ruining Line's user experience, many services wanted to restrict this from their services. To make adult content filter, Line China AI team participated. They started this project based on ResNet 50, and this model classifies images into 3 different classes, which is adult, sexy, and normal, based on how erotic it is. And they used about 3.5 million training samples to train their model. And they evaluated their model with about 1 million samples. The quality was very nice, and we got F1 score of over 0.9. F1 score is the most commonly used model quality metric. And they kept tuning the model, so they got outstanding performance, which is less than 300 milliseconds. The performance and the quality were good enough to put it in service. So we could finally apply this adult content filter to some of Line services, and we could filter out some users abusing with adult content. We were satisfied, and more services wanted to use this for their services. And as we integrated more services, it was really difficult to handle all the request volume, especially in peak time. So we had to do something. Here's our approach to handle massive request volume. First, we put Kafka inside. This is to throttle requests in peak time. And we developed a new gateway providing both sync and async API. Gateway writes all the incoming messages into Kafka. Sync requests and async requests are written on their own topic. And then we developed Pacman to process requests in Kafka. Pacman has priority queue inside, and sync request processing comes first. We allow sync API only for services which need real-time processing. Async request processing is done when you have enough resource left by sync request processing. So we could adaptively handle soaring requests in certain time. For async request, of course, we have to send a callback to services. While we are sending callback to service, some of the callback were missing. It could be because of network problem or service server deployment or any other issues. Missing callback can produce unexpected problem in service, so we have to ensure that callback is sent. So we developed dead letter queue based on Kafka. The mechanism of dead letter queue is quite simple. Publishers keep publishing messages into message queue, and consumer consumes and processes them. If consumers successfully process messages, then consumer send acknowledge to message queue. But if consumer failed processing message, then consumer send neck instead of acknowledge. Then the failed message automatically goes into dead letter queue and stays there for a certain time. And after TTL is expired, then the message goes into message queue again so that consumer can process it again. So we put dead letter queue based on Kafka and Spider-Man into PicCell. Spider-Man was developed for guaranteed callback. Spider-Man works as a consumer and it keeps trying to send callback until it succeeds. Spider-Man never misses callback like Spiderweb. We have been stabilizing PicCell like this, but still we have things to improve. Another problem was that we kept receiving same images. It could be due to users sharing their favorite pictures or some kind of social issues. Of course, we can process them all, but we need GPU resource for adult content filtering. And GPU server is extremely expensive compared to ordinary servers. So duplicated processing is waste of GPU, and it means waste of money. So we put Redis into PicCell to cache the result. All the results from Pacman are written on Redis. And Gateway and Spider-Man deliver them to clients. Every time Gateway receives request, Gateway searches cache the result in Redis. If it's not in Redis, then processing should be done. But if it's in Redis, then Gateway can reuse cached result. This is how we saved a little bit of GPU resource. So we could clean most of abusing images from line services, and it went well for a while. But Line has been focusing on video service, and numberless of video is being shared by users. And for other content, video influences more than image. So what should we do? Should we develop a new deep learning functions for video filtering? Well, actually, we spent a lot of resource to develop other image filter. So we just applied a simple approach for this. Looking at the structure of video, it's just a simple group of pictures. So we can sample some frames with certain time interval, and we convert them to JPEG. Now, video became a small group of images. Then we can apply our adult image filter to them, like this. After all the processing for every single image, we can aggregate or inference the result of video. It's quite simple. So we developed Timberman. Timberman extracts snapshots from video and converts them to JPEG. Thanks to Timberman, All the processes inside PicCell can be really simple because all the components can focus on image filtering process. The results of all snapshots are aggregated by Pacman. So finally, we could process all the images and video with PicCell. So we could make the most pleasant line ever. And we were satisfied too. But one after another, we faced with another problem. Line has its own social network service, which is called Timeline, and this is one of the most popular family service of Lines. As more users we have, more of users we get. For Timeline, adult content was not the only one problem. Since all the posts are exposed to anyone, there are many users with illegal advertisement. We could process most of adult content with PicCell, but for illegal advertisement, we got nothing. So we started to work on illegal advertisement detection. We looked inside to see what kind of parents are in this illegal advertisement. The first goal of these users is selling imitation products. Most of them are imitations of luxury items. And the second one is done by QR code. They just put QR code on images to guide users to their own illegal website. The last one is overlaying advertising text on image. We noticed these three kinds of patterns in illegal advertisement. So we started to do the divide and conquer. To find imitation product advertisement, we listed up some popular items, such as sunglasses, and shoes, watch, and handbag. And we made a classifier based on Google Ads, classifying images into these 4 categories. And it was quite successful. Second one was very simple. We just applied QR reader and analyzed its extracted link. It was also nice, and QR reader, it even runs on CPU well without GPU. This was the most difficult part. We had to understand text on image to figure out whether this is advertisement or not. So Line AI team started to develop OCR, and its difficulty was much higher than another job. Because Line is running services in many different countries, we had to support various languages. Finally, Line AI team developed OCR supporting Japanese, Korean, English, Thai, Taiwanese, Chinese, and Indonesian. Even vertically written Japanese is supported. So we put these 3 new models into PicCell, and we started to filter out some illegal advertisement in timeline. Finally, we could restore timeline's user experience a little bit, but our users are changing their patterns all the time. So we will keep working on it. Let me get some drink. This is about us learning a lesson from trial and error. Line is running 2 kinds of Line Live service now. One is for Japan, and the other one is for Europe and Middle East Asia. Since this is kind of video service for various age groups, we have to block all the harmful broadcasting from our users. Besides erotic video, we noticed lots of harmful things in video, such as arms reminding users of violent scene or smoking people. And because these services are running across the world, we had to deal with sensitive symbols. So Line AI team developed a new deep learning model to find them all. This new model can find these things regardless of the size and the location. So problem solved again. But somehow our adult content filter didn't work well. F1 score for these services dropped to zero point 0.3 from zero point 0.9. So we researched this problem and we came to a conclusion. We have been training our adult content filter with samples from general services, but erotic scene from Line Life is somewhat different. I cannot explain in detail here, but it's different. So we realized that we need to train our model with samples from actual services. So we have decided to store some samples along with their own attribute, like country or the inferencing result from PicCell. We can store samples if and only if user consent has been made, or some could be stored by operators' manual disciplinary actions. And we had to develop some kind of gateway to deliver these samples under strict restriction. To access these samples, legal review for permission should be done in advance. After legal review is done, we issue access token for only who acquired permission. This access token has the information of data range it can access. So we developed Librarian to serve training samples to deep learning engineers under strict restriction. And we put Librarian into PicCell to support service-specific training. Thanks to Librarian, we could provide training samples from Line Life services, and adult content filter has been significantly improved on these services. With this trial and error, we are still improving PicCell and its own deep learning functions. And as we get better, more services integrate with us. So the traffic we are handling is also tremendous. The most popular adult content filter processes about 15 million images and video a day. And the other features for illegal advertisement detection, they processes about 20 million images a day. So we could dramatically reduce the number of contents which operators have to monitor. As we improve PicCell over time, the monitoring cost goes down, as we can see. Of course, we cannot run all the services without monitoring operators, but we are still trying to reduce their stress. We have talked about why and how PicCell was made. Despite the performance of back-office support, we were not satisfied with what we had done. So we tried to step forward. Like Line's slogan, closing the distance, we wanted to get closer to our users. we wanted our users to experience PicCell. The first try was OCR. This is actual result from PicCell, and the quality is quite nice, as you can see. Like I mentioned in the beginning, Line's OCR service is powered by PicCell's OCR and Line translation infrastructure. You can try this after this session. Here's another interesting application. You can experience PicCell. This is very unique application, only available in Indonesia. When you eat some food in a restaurant, we usually share the total expense. But in Indonesia, they have very unique expense sharing code. They share the expense only for the menu they actually ate. I think this rule is very reasonable, but this must be very complicated and take some time to calculate. So here's the service for it. Users can simply capture the receipt, and PicCell analyzes attributes like name, quantity, and the price for every single menu. Then users can assign people who actually ate for each menu. Then the amount to be paid by each member is calculated automatically. We are just focusing on calculating prices for now, but we have a plan to apply Line Pay for easier money transfer in near future. And this was possible thanks to Clover AI team. They have their own Indonesian OCR, and they are really good at understanding documents with their own NLP processor. This is only available in Indonesia for now, but we are planning more applications for everyone with this document OCR. So we put Clover Vision AI technology into PicCell. We are discussing with Clover to secure more useful deep learning functions, and you can look forward to it. This is another case study, and this is about PicCell expanding into financial area. Line Finance is providing very useful services in many countries. To join their services, users have to verify their identity, which is called KYC. KYC is short for Know Your Customer. For KYC, users have to visit bank or some kind of financial office. And there's another type of KYC, which is called eKYC. eKYC is paperless online KYC. They can just enter their information and the picture of their ID card. Even if eKYC is done online, they still need so many operators to review all the requests. And Line Finance realized that they should automate some part of this procedure. So PicCell got involved to automate eKYC procedure, and PicCell started to expand into financial area. For eKYC automation, PicCell prepared some features. The first one is ID card recognition. We can compare user-entered information with recognized one from ID card, and if they all match, we can say the information is correct. Clover AI team helped us again. Since they have outstanding skills in NLP and OCR, they could develop a new ID card recognition model. For now, only Japanese driver's license is supported, but we can support any types of ID cards as long as service needs. And second one is face verification. To ensure that the request is from actual users, we can compare face picture captured in real time with one in ID card. This is also developed by Clova. And did you see face check-in service when you got here? It's quite fast and accurate. It's same model with this, and you can meet this one through PicCell. And since we have to handle personal data, we built a new infrastructure fulfilling all the requirements from security team. This is blocked from all external access, and all the data is completely removed after processing. Line Finance eKYC is the first case of PicCell supporting financial solution. But this approach will be applied to another line's financial service, and we are discussing with them to provide more pleasant line's user experience. This is what we have been doing for PicCell and services using PicCell. Now, I'd like to introduce our two plans for the near future. We are planning to build a deep learning training sample portal. The main goal of this is to provide the most valuable training samples on service demands. This will be done by two steps. And the first one is correction API. As I mentioned before, PicCell stores some incoming samples with their own attributes. And when service sends PicCell's result is wrong, then they can mark or correct result stored in PicCell with this API. This will help us to refine and purify training samples in PicCell. The second step is librarian supporting simple query. Service may need specific part of training sample, and they can choose samples from specific country, or they can choose only corrected samples. I think corrected sample set is probably the best to compensate for the weakness of model. With these two steps, we will provide the most efficient training samples to deep learning engineers. And this is our second plan. Some of you might have experienced this. Microsoft Cognitive Service, Amazon Recognition API, and Google Vision API. They are all providing Vision AI functions to various services. And these are the reference of what we are planning. We like to open our API to public too. We also have very powerful infrastructure platform, which is called Verda. Verda has been providing various cloud server applications. If we can integrate PicCell with this powerful infrastructure platform, we'll be able to provide well-made Vision AI functions to service easily. Maybe next year, we will be able to provide PicCell's functions to any company's services. This is my favorite slide, and I'm gonna wrap up today's presentation with this page. PicCell has been working on making virtuous cycle between line services and vision deep learning technology. We will keep improving our vision deep learning technology via Line service, and Line services will take benefit from it. So all of you will experience a smarter Line than ever. You can look forward to it. Thank you for your attention, and I hope you fully enjoyed this. I am Junshik from Line Plus Media Platform, and please enjoy the last of the day session. Thank you.